The Lockheed A-12 was a highly advanced reconnaissance aircraft developed by Lockheed's Skunk Works division for the CIA in the early 1960s. A precursor to the more famous SR-71 Blackbird, the A-12 was part of the United States Cold War strategy to gather intelligence on the Soviet Union and other adversaries through high-altitude, high-speed reconnaissance missions. It was a single-seat aircraft with a length of 101 feet and a wingspan of 55.6 feet. Its maximum takeoff weight was approximately 117,000 pounds, and it could fly at Mach 3.2 at altitudes exceeding 85,000 feet, allowing it to outrun and outfly any known Soviet interceptors or surface-to-air missiles of the time. It had a range of over 4,000 miles and was equipped with sophisticated optical and electronic intelligence gathering systems, including high-resolution cameras designed to photograph large swathes of territory from extreme altitudes. The A-12's cameras could capture images with a resolution sufficient to identify objects as small as 30 centimeters, far surpassing the Corona satellites of the time, which had a resolution limit of 12 meters. This superior capability made the A-12 invaluable for aerial surveillance. The A-12 was a delta-wing monoplane with an innovative design that combined stealth, speed, and durability. The delta wing had slightly washed-out leading edges and was seamlessly integrated with the engine nacelles and fuselage, extending to the nose. This design aimed to enhance structural rigidity, divert radar reflections, and improve stability and lift without compromising speed. The A-12's designers sought to reduce radar cross-section. The airframe was designed to avoid protruding elements and incorporated sawtooth-shaped joints. These joints connected sections of the airframe coated with radar-absorbing materials. The A-12 was tailless with elevons, hybrid control surfaces performing the functions of both ailerons and elevators, positioned on the wing's trailing edges. Its vertical tail consisted of two small, all-turning fins mounted on the engine nacelles and angled inward. While this design enhanced aerodynamics and stealth, it also caused significant stability issues, especially in early models. Advanced stabilization systems were gradually introduced, but overcoming these issues required substantial effort. The landing gear consisted of 3 legs which, upon retraction, were stored in a fuselage niche between the fuel tanks, an area cool enough to prevent the wheels from melting. The wheels were designed with intricate aluminum mesh encased in rubber and inflated with nitrogen, which helped extend their life to approximately 20 flights, a significant achievement considering the high takeoff and landing speeds, over 170 knots, and extreme temperature variations. A braking parachute, stored in a compartment near the tail, assisted with reducing speed during landing. The A-12's fuel consumption was immense, burning 15 to 20 tons per hour during flight. The aircraft needed a substantial amount of fuel for long-range missions, so most of the fuselage was dedicated to fuel storage, as the wings were too thin to hold a sufficient amount. The fuselage's interior essentially served as fuel tanks similar to a wet-wing design. These tanks could hold up to 31 tons, 68,300 pounds of kerosene. However, a unique challenge arose from the thermal expansion and contraction of the airframe's components. When the A-12 was on the ground, the airframe contracted, causing the tanks to leak. Due to the high temperatures the aircraft would face in flight, the standard kerosene used in most aircraft would boil. Instead, the A-12 used JP-7 fuel, a highly stable, specially formulated fuel with various chemical additives designed to withstand the aircraft's extreme operating environment. JP-7 also served as a coolant for the aircraft's internal systems, preventing components from overheating. One of JP-7's characteristics was that it was so stable it wouldn't ignite easily in the afterburner chamber. To address this, the A-12 used triethylborane TB, a pyrophoric substance that ignites on contact with air. TB's high combustion temperature provided the necessary spark to ignite JP-7 in the afterburner. The result was a distinctive green flame when the afterburner engaged. Despite its importance, TB came with its own risks. It was highly flammable, requiring special precautions during refueling. The TB tank was small, limiting the A-12 to about 15 afterburner starts per flight. The A-12's flight range was about 2,500 miles, 4,600 kilometers, which, while impressive, was insufficient for long-duration strategic reconnaissance missions. To extend its range, the aircraft was equipped for aerial refueling. However, refueling the A-12 was not straightforward. The aircraft's maximum takeoff weight was 53 tons, but fully fueled and equipped, it exceeded this limit by 5 tons. To compensate, the A-12 took off with partially filled tanks and refueled shortly after takeoff. The A-12 was powered by Pratt & Whitney J58 turboramjet engines, a highly specialized system that allowed the aircraft to transition from turbojet to ramjet mode during flight. At lower speeds, the J58 functioned as a traditional turbojet, with additional bypass circuits to cool the engine. As the aircraft accelerated to higher speeds, the bypass ducts played a different role, ejecting excess air and boundary layer flow. The engine's performance was enhanced by a movable inlet spike, made from heat-resistant plastic with a titanium tip. As the aircraft increased speed, the spike retracted up to 66 centimeters, 26 inches, to control the formation of shock waves at the engine inlet, ensuring stable airflow into the engine. At Mach 3, the J58 operated mostly as a ramjet, with only 17.6% of the thrust coming from the turbojet. The A-12 was designed to fly at sustained speeds of Mach 3, with surface temperatures exceeding 250 degrees Celsius (480 degrees Fahrenheit). Traditional aircraft materials such as aluminum could not withstand these conditions, and while steel was an option, it was too heavy and would drastically reduce the aircraft's range. The only feasible material was titanium, known for its strength and lightweight properties. However, the U.S. faced a shortage of titanium, and the only other country that could provide the required quantities was the Soviet Union, the very country the A-12 was designed to spy on. Through covert operations led by the CIA, the U.S. obtained titanium from the USSR via a network of resellers. Manufacturing with titanium posed significant challenges, as it was difficult to work with, especially when producing complex aircraft components. Lockheed had to redesign its production processes and develop new machinery to handle titanium. In the early stages, many parts were discarded due to defects. During temperature testing, large wing panels showed signs of degradation and shrinkage, which could lead to in-flight structural failures. The solution was to corrugate the panels, which allowed them to withstand extreme temperatures without warping. In the end, the A-12 was able to handle surface temperatures up to 260 degrees Celsius (500 degrees Fahrenheit), with allowable peaks of 315 degrees Celsius (600 degrees Fahrenheit). The A-12 had a single-seat cockpit. The cockpit canopy, designed for high-speed performance, was wedge-shaped with thick quartz glass sections. This design, while durable and able to withstand temperatures exceeding 300 degrees Celsius, significantly limited the pilot's visibility. The pilot wore a pressure suit adapted from NASA's astronaut suits. The A-12 was equipped with a sophisticated suite of avionics for navigation and reconnaissance. It carried a Hicon Type 1 camera system in its nose, capable of taking high-resolution photographs from extreme altitudes. The camera had a focal length of 18 inches, and its position inside the nose allowed it to capture broad areas of terrain with incredible detail. The A-12 could also carry electronic intelligence systems for intercepting and analyzing enemy communications and radar emissions. The A-12's reconnaissance equipment, adapted from the U-2 program, faced additional challenges due to the aircraft's high-speed, high-temperature environment. Cameras and sensors had to be redesigned for temperature resilience, with cooling systems integrated into the equipment. The primary cameras were housed in the Q bay behind the cockpit, with additional compartments located under the fuselage and in the nose. The first flight of the A-12 took place on April 25, 1962, at Groom Lake, Nevada. After a series of test flights and refinements, the A-12 achieved its first operational mission in 1967. The aircraft was deployed during the Vietnam War under Operation Black Shield, where it conducted reconnaissance missions over North Vietnam and Laos. During these missions, the A-12 demonstrated its capability to operate in hostile environments, collecting crucial intelligence that could not have been gathered by other means. The A-12's operational career, however, was short-lived. By the late 1960s, the U.S. Air Force's SR-71 Blackbird, a two-seat derivative of the A-12, had entered service. The SR-71 offered similar performance but with additional capabilities, such as more advanced sensor packages, and the ability to carry a second crew member. The SR-71 took over the A-12's reconnaissance role, and in 1968, the A-12 program was officially terminated.